Okay, so start off by separating your variables, or sorry, cross multiplying, and then deciding if we need to have our variables separated. After you cross multiply and get all the denominators moved up, we should at least have our dy dx's in the right places, right? Dy's on the left, dx on the right, and then we got to decide, okay, do we need to move anything else? But I think in this case we're good, right? Y's are grouped together, x's are grouped together. No need to divide anything over, so we can move to the next step. Both sides we can use what rule? Power rule, yeah. They're both set up for power rule, so. Even if it says to find just a particular solution, I think it's always good to kind of have a goal in mind in terms of getting to a general solution before involving the order pair. So I think in this case, we're not going to be able to get the y. There's no y squared, there's no natural log, but there will be a y cubed. So if we can get that y cubed by itself, it's not a true cleaned up solution, but it is a nice general solution. It's relatively cleaned up, and it allows for your C value to be inserted in and solved for without too much trouble. Yes.
So would you move like the 1/3?
Yep, I would multiply everything through, but yeah, good. I'll distribute that 3 through so that I can get that left side a little bit more cleaned up. And then I'll call that the general solution, and then I can involve the order pair to solve for C.
When we plug it in, can we plug it into like the y cubed part?
That's what I would do, yeah. I would plug it. Now, technically, you can solve for C as soon as it shows up, but I think it's nice to have it a little bit cleaned up before you involve the order pair. So I like to plug it in this stage rather than this stage. Okay. Now, the 3 distributes to everything. Even the C, it's just that the C kind of just sucks that 3 in. So we don't have to put a 3C for that general equation. Okay. So at this point, I would now involve the order pair. Okay. So -1 in for x, 3 in for y, solve for C. Now that I have y cubed equals -3x squared plus 30, what's the final step? Take the cube root. Okay. Now, cube root, there's no plus or minus, right? Plus or minus is only for square roots or even roots. So there's no need to make a decision. That is our answer. There's no need to choose between options. So there's only one solution, and that's the cube root. Okay, any questions with 1? Okay, I'll leave this up here for another minute, just so that you guys can catch up. But if you're good with number 1, go to number 2. Okay, I want to just see how you guys do and see how you guys set up your equations. Okay, there's y prime here, right? So what can we do first? Yeah, let's get that dy dx and see if you can at least get it to be a nice clean fraction equals to a fraction so they can cross multiply and then make their next decision. So I replaced y prime with dy dx, and I just had that dx kind of share the same denominator space as that 3 minus x. Cross multiplied, and I just want to protect that 3 minus x a little bit. I left the parentheses around it, so I didn't want it to get mixed in with the y, but you see that once you cross multiply, at least you have your dy dx's in the right spaces. But then the one thing that's out of place is that y, right? And now the 6 doesn't have to go along with it. The 6 is next to the y, but we don't have to move the 6, right? Just have to move the y over. Left side is natural log. Here, just be careful that when you see that parentheses, it doesn't mean that it's a U substitution problem. Or you always want to try to avoid U substitution if possible, right? You always want to see can I expand and distribute. Here, we don't need U substitution. This is manageable with just power rule if I just distribute that 6 through, right? Okay, natural log on the left, power rule on the right. Okay, go through your steps. Natural log, do a little bit of cleanup. Okay, so everything is up at the function level. We want to solve for y. What can we do on the left side, on both sides, actually? Right, I want to undo that natural log, so raise both sides, base e. Now, you see 3 terms on the right side, but we don't need 3 separate e bases, right? All we need is 2. We just need to separate the c away from the variable, so we don't have to separate the 18x and minus 3x squared. Just separate the constant away from the variable, because we just want to be able to get that times c to show up. Again, anytime you go through this process, just remember that this plus c is all of a sudden going to be in the exponents, so if we want to bring it back down, it's going to become a multiplication. Make sure you adjust that change in your operation. No longer addition is now multiplication. C comes out in front, drop the absolute value, and now you have your general solution. Once you're sitting at your general solution, you can move to your next step, which is working in your order pair. Okay. Try that. Two in for y, 0 in for x. Careful, whenever you just plug in 0, go through and just make sure that, I think the tendency is we plug in 0 and we just want to naturally assume that everything will just go to 0. But in this case, this 0 is in the exponent. E to the 0 is not 0, e to the 0 is 1. But it does go away, leaving up the c equals 2, and then replace the 2 in for c. Okay, I'll leave this up here for another minute, but if you're ready, try number 3. Okay, so here's everything up to the general solution here. I know that we've done so much natural log that we expect it to just happen every time, but gotta make that decision yourself, right? Here, when you cross multiply, it's not 1 over y, it's y in the numerator, so we do power rule there. So we do y squared over 2. But once you cross multiply, you saw that all your y's and x's are lined up nicely. So, and then we look at each term individually, power rule on the left, power rules on the right. And then I know that I'm not going to work my way down to square root of y just yet, or square root on either side just yet. So I'm just going to try to get that left side in terms of y squared, and that is a good general solution place to be, because my next step is going to be easier without having to deal with a bunch of square roots. So I distributed everything through by 2 just so I can get that left side a little bit cleaned up, but I like that y squared to be, yeah, I like that it's relatively clean, and it makes it easy for your next step to plug in. Okay. Any questions up to the general solution? Okay, so now involve your order pair, -3 in for x, 6 in for y, and solve for c. C equals 12. Update your general solution with 12. And now we're one step away, and that is to do what? Take square roots. 2 solutions will pop up, a positive and negative square root. Which one do we choose? Positive, because of the y value. Right? You look at the y value of the order pair. You want whatever sign of your answer to match the sign of your y value. Okay, try number 4. put the answer, we'll show the work. Okay, so here's the work. Up to the general solution, cross multiply, natural log on the left, power rule on the right. Raise both sides, base E, separate the right side, bring that C out in front. So there's your general solution. Okay. Y equals CE to the x cubed over 3. So now the order pair gets involved. 3 in for x, E in for y. E equals CE to the 3 cubed over 3. 3 cubed over 3 is 9. I want to get that C by itself. Divide both sides by E to the 9th. So we can merge them together. Either we can bring that 9 up to the top and make it E 1 minus 9 is negative 8, or bring the E down to the denominator, 1 over E to the 8th. It's really up to you. So once you have whatever C value variation you have, you can now insert into your equation. So either form is fine, right? You can either have it as e to negative 8 or 1 over e to the 8th. But I will say that there is one step further that you could go. It's not, you're not required to. But if there's multiple choice and you're trying to figure out why is my answer choice not here, it's maybe because College Board may sometimes merge and try to clean up a little further. So what's another way that we can write this?
E to the x cubed over 3 minus 8.
Right, so they end up merging the exponents together and writing it as the sum or difference of the exponents. So, but if it's free response, any of these variations will be perfectly fine. Just wanted to let you know that sometimes if you're doing multiple choice, your correct answer may not be in the solution because it's a different form. All right, I'll leave this up here for a moment. Try number 5 when you're ready. Okay, we got to deal with that W prime, right? This is no longer X's and Y's. This is now involving T and W. So whenever you see a variable that you don't recognize, remember T is your X, your quote unquote X, and then whatever the other variable you don't recognize, that's going to be your Y. So how can we rewrite W prime?
DW.
Good. dW over dt. Good. So your dependent variable is going to sit up top. Your independent variable is going to be in the bottom, and then now you can get that fraction to show up and then cross multiply. Once you have to cross multiply and separate the variables, left side is power rule, but the right side, we have to involve what? Substitution, yeah. That 2t cubed. That's, yeah, I mean, we always want to try to avoid use substitution if we can, but this is just too complicated, right? We don't have a rule that's as messy as that, so we have to get it down to a simpler form. And we also deal with that 2t cubed, because there may be a coefficient that we got to keep track of. There's going to be a 1/6 that's going to come out of it. The t squared will cancel out nicely. Okay. This is one of the original integral rules here. You guys remember what integral of secant squared turns into? Tangent, yeah. Tangent derivative of secant squared, so therefore the integral of secant squared will bring us up to tangent. Power rule on the left side. We see w squared, so that just indicates that we're not going to be able to quite get it down to a very clean, I mean, we're not going to get it down to w, but at least we get it down to w squared, right? So let's multiply everything through by 2. Get it to w squared, and I think that will be a clean spot for us to take our next step and involve our working towards our particular solution. Order pair, 0 in for t, -4 in for w. Tangent of 0 is just 0. That goes away nicely. C equals 16. Update your equation. And then one final step. Take the what? Square root. Which one do we choose? The positive or negative? Good. Because the y value, right? -4, that's going to help guide which answer to choose there. We want the negative square root because we want a -4 to show up.
Could you explain why you chose the negative one?
The reason why is because it has to satisfy this order pair. I have to be able to plug in 0, and I have to get a -4 back in return. Because I have to, this point has to live in my solution. So the only way it's going to live if there's negative in front. So if I plug 0 in, the only way I get a -4 is if there's negative sitting out in front. There's no negative with this positive square root, so even if I get a 4 here, it's not going to get me to that order pair. Okay. All right, good. Any other questions with 5? Okay. Try number 6 whenever you're ready. So what I would do at this stage, because of what we have here, I would do this. Feel like that's.
I can just do that. I can just get rid of the y.
Well, I just move that y over, right? Because these are connected. I can make that one fraction. I can move that y over and separate, and then now I can cross multiply. 0.
Okay.
Now I can decide.
Just multiplying back.
Right, so what needs to move? What's out?
This y, x on.
Yeah, so to make them swap places. So they're going to both go to the denominator of the other side. Yeah, it seems strange, but the important thing is that your dy dx is up top. That's what one needs to do there. Okay, so this feels a little bit strange here with number 6 because when you clean everything up and you cross multiply, your dy dx's need to be up top, but then all the x's and y's are out of place, so they're both going to divide over to the other side. All your x's and y's are going to end up in the denominator. But don't feel like that's wrong and you want to move it to the numerator. It's okay. We have rules that can handle denominator. We just need that dy dx up in the numerator. So those are kind of like your anchor variables. But wherever the x's and y's have to move, we just then decide, make that decision based off of the y's have to be on the left and the x's have to be on the right. Okay, left side should just be a natural log rule, but the right side we have to go through what? U substitution. Okay, what's the u value that will make this work? Yep, natural log of x. Okay.
So it would be 1 over x.
Okay, we let the u value be natural log of x, du over dx. Remember the derivative for natural log of x is 1 over x. Cross multiply, dx equals x du. I just want to replace what I underlined, replace natural log with u, replace dx with du. Sorry, replace dx with x du. X is canceled out. I'm left with 1 over u du. So now I can involve natural log once it's cleaned up. And then replace the u back in terms of your original variable, which is natural log of x. So it's natural log of x plus c. Yeah.
What's the derivative for x?
Oh, derivative for natural log?
Yeah.
Yeah, so the derivative for natural log of u is u prime over u. So therefore, natural log of x is 1 over x.
Oh.
Okay, we keep going. We want to resolve that, get that natural log to go away from the left side. Raise both sides, base e.
Wouldn't it cancel out on 2 sides?
Yeah, it would, but I'm going to separate the right side first, and then eventually, yeah, the right side will clean up a little bit more. But initially, I'm just going to separate that c away from that first term. And yes, now I can make this drop. Any steps along the way you want me to clarify? I'd be happy to. Let me know. Okay, so now we're at the general solution. We can involve the initial condition, E in for X, E in for Y, and try to solve for C. Once you have your C value found, just update that general solution with a replaced specific value for C.
So what is natural log?
Oh, natural log of E is 1. Yeah, natural log of E is 1. So that's why I can just let it drop just to go away. Okay, I have one more problem for us. You guys can put this at the top of page 22. It's a blank page here. So number 7. You guys can write this down here. Y prime equals. And then your order pair is Y of -1. So same steps as before. Separate the variables, solve, take the antiderivative, get your general solution. And then once you have a general solution, then you can use the order pair to find your particular solution. Okay, does anybody still need to look at number 6? Okay, I'll leave it up here for a second. Good, okay, thanks. Mm-hmm. Yeah, good question, right? Natural log is only x to the first power. You have to power. Where does it have to be for power? And then, yeah. This one here? Is it this problem? Okay, let me go through at least the initial step here. So cross multiply, and we should be able to see that dy dx is in the right place, but there's one thing out of place, and that is that x is the x squared, right? Divide the x squared over, right? And we have this step here. We have y dy equals 1 over x squared dx. Left side, we recognize that as power rule. Let's talk about the right side, though. How do we handle that right side? Right, also power rule. I think because we see the variable in the denominator so much, it's easy to kind of just condition ourselves to think that it's always going to be natural log. So why is this not natural log? It's x squared, right? Remember, there's only one condition that we use natural log if it's x to the first power in the denominator. If it's x to any other power, we got to force it up and then go through power rule. Right, so I want to make sure that it's a very slight but important distinction. We have to, these rules are easy by themselves, but when they're mixed into different problems, sometimes it's kind of hard to differentiate the rules. So I want to point those out. Okay, so power rule on the left, power rule on the right. Okay, keep going from here.
Then it should become negative x squared, or negative x to the negative.
Y squared shows up on the left. So I'm going to clean up the right side, but I'm also just going to try to get that 2 to move over to the right side as well. If I get that y squared by itself, I can kind of box that off and give it a general solution name, and then I can move to the next step. Okay, so there's my general solution. Okay, so now you can work in your order pair. Okay, any questions up to the general solution? Okay. -1 goes in for x, -2 goes in for y. Solve for c, we get 2. Update our equation, we get y squared equals -2 over x plus 2. Take the square root. So which version do we choose?
Positive.
Look at the, how do we decide again?
Oh, the order pair.
Mm-hmm.
Oh, -2.
Yeah, -2, right?
On that it says 2, positive. So
Oh, sorry. My bad.
that's why it said positive.
Got it. I copied it wrong on my, okay, sorry about that. So -2 in for y, -1 in for x. You choose the negative because the y value is -2. Okay. Okay, any questions? Okay, just a reminder, I'll send out a reminder this afternoon as well. For those of you who want to do recovery tests, that'll be tomorrow, come in anytime, morning, lunch, or after school. But make sure that you have either come in during lunch or after school today to do the corrections so that tomorrow you can take that recovery.
Is the calculator portion in?
It's not in yet. I'm almost done with the calculator portion. Yeah, just the first part. I'll enter the calculator portion into the grade book, hopefully by tomorrow. And then if you do recovery, we'll have a week to get that underway.
And the recovery is only to 79?
79.
In the order pair, the y value is yeah, you take the sign of the y value.
I didn't say it. Yeah.
I could have got that same thing.